Everyone, my name is Javneet Singh, and this is my favorite slide. And the reason is because I am the only one with the double affiliations. So I am an engineering science student at Faculty of Life Science Geography and interning at the Department of Physics. So let's start with the presentation. Assessing wildfire impact on air quality using ground-based and satellite instruments. Current wildfires. It's a nationwide crisis. Over 7.3 million hectares have burned this year, making Canada's second worst fire season on record, according to CBC. There are different types of fires, and one of those is like the out of control fronts. More than 470 wildfires remain uncontrolled within the Saskatchewan and Manitoba region. Other affected regions include Ontario, BC, Quebec. These are some cool photos of the wildfires. So, can we detect smoke plumes from wildfires in downtown Toronto? The key wildfire pollution indicators are carbon monoxide, which reduces oxygen delivery in the body, causes headaches, dizziness, and fatigue. Nitrogen dioxide, which irritates the lungs, worsens asthma and respiratory conditions. Formaldehyde, SCHO, it's a classified carcinogen. Long-term exposure increases cancer risk. And why all of this matters? Because these gases also significantly degrade air quality, which is measured by AQI. So, wildfires and air quality. Multiple wildfire smoke plumes impacted Toronto between May to July 2025, which was also the period during which I was interning at the lab. Toronto had the second worst air quality in the world on July 13, 2025, according to IQ Air. The study combines ground-based and satellite measurements. So let's move to the main figures part. I wanted to introduce how a smoke plume looks. It's just an example, nothing specific of any time period. Now this is the main figure of our project. This is the air quality index directly over the MP Philly slabs. Somehow I found out like the IQ Air website, they supply instruments to different people, and some anonymous person also has installed this instrument at our MP lab. So this is just specific over here, not overall Toronto. So the colored shapes are time intervals of interest when major smoke plumes originating from wildfires pass over Toronto, which is this pink diamond. And this is the part, so currently, when the presentation hadn't started, I put up a slide. So currently we are also facing some smoke plumes, but I don't have the data for the Tau FTIR right now with us, but we are still retrieving the data. The University of Toronto Atmospheric Observatory, Tau, which is just above the Burton Tower where all the offices are. It houses ground-based instruments for atmospheric trace gas monitoring. I have been working with the tower retrievals, like just filling a link to switching it on and off. This is a group filling in liquid nitrogen into Tau FTIR. So the instruments used in this study: Fourier transform infrared spectrometer, Pandora, and Tropomi, which is a satellite-based instrument. FTIR and Pandora are ground-based Tau instruments up on the roof, whereas the Tropomi is housed on the satellite Sentinel-5P, which is of the ESA, European Space Agency. FTIR uses infrared absorption spectroscopy, whereas the Pandora uses UV visible absorption spectroscopy, and the Tropomi uses the Navier viewing spectrometer measuring backscattered light. So how these two are different is that FTIR only directly looks at the sun, whereas Pandora can directly look at the sun and also the backscattered light at different angles. So it has a little bit of advantage here. This is affiliated with NDAC. There is a full form here, PGN, Pandonia Global Network. The project gases were CO and SCHO for FTIR, NO2 SCHO for Pandora, and all of those for Tropomi. These are some cool pictures. Here I am imitating the Pandora. I don't know if it's of interest to you. Yeah. So to understand the results, we need to know like ground versus satellite-based instruments. Ground-based instruments offer precise measurements at a fixed location with high temporal resolution, which means multiple measurements per hour. Whereas the satellite instruments have global spatial coverage for identifying pollution transport pathways. And I will show you the maps of the clouds over Toronto, which the introductory slide had an example of. This is an example picture not specifically of Tropomi satellite, but this tells you what is the path of the satellite, and it covers different parts of the world at different intervals of time. So all of the measurements are not coincident at the same time interval. total versus tropospheric column. Total column is the amount of gas through the entire atmosphere surface to the top, from here to the here. It is useful for long-term trends and total atmospheric burden, whereas the tropospheric column, it is the amount of gas only in the troposphere, which is somewhere here in the figure. Tropospheric values better reflect air quality impacts at the ground level, which is why it's important. So the results. The time series of total column, which was like full column, from May through July 2025, the period during which I was working, were plotted, and the variation in the gas columns were analyzed by looking at the snapshots of Tropome spatial concentration maps at time intervals of interest, which were the colored marks, like pink diamond. So let's go to carbon monoxide. This is the time series from May to July 2025. The orange yellowish plots are for Tropome, which is the satellite-based instrument, and the FTIR is the ground-based. The most beautiful part is you can see like the peak cover lines for both of them, and the main results are in the next part. So above we have the FTIR CO total column. The circle marks the location of Toronto in the lower figure, and the corresponding time periods from May to July are also labeled according to the color of the figure. So during May, when there was the wildfire just start around this time, there were smoke plumes reaching Toronto here. You can see the CO total column is pretty lower here, and you can see no clouds from the satellite view. During June, when the wildfire near the Manitoba region had already started, there is an increase in the CO total column, and you can also see the map from here. This is where all the wildfires were, and still currently are. Then during July, there was a dip when this cloud had already passed, and now we are also seeing another smoke plume passing over Toronto during the August. While everyone was waiting, I played a video of the smoke plumes, which was the live, and some of it was analytical. Yeah, so I don't have the FTIR retrievals for this one. SCHO, formaldehyde. Here also the yellow ones are Tropome, the other ones are Pandora, which was looking at the measurements from different angles as well. They seem to correlate, but the thing is Tropome, as I showed in the figure earlier, it doesn't have all the measurements at like coincident same time intervals, so it keeps rotating, and thus it has like less measurements overall. So during May period, there was less forest fires, they hadn't just begun. You can see there is all of blue, less green clouds. During June, the green clouds appear near Toronto. Then again, May, June, July. This is supposed to be July. This cloud has already passed, and then during August, which is like right now, there is again smoke plumes passing over Toronto. The pink diamond was July 13th, which I quoted earlier, which had the second worst AQI in the world. So you can clearly see a peak here. Now we come to NO2. Now when I look at it from here, I suppose there's something wrong with the figure, because the Tropome isn't aligning, it's always near the base region. I wonder what the reason is. So this was the thing that I found out yesterday practicing out. So we made a column and time of day map instead of the time series. So here the red is the Pandora part, this is the tropospheric column NO2, and the Tropome measurements were all made from 12 to 15, which is like the afternoon period. So the thing is, NO2 is a different kind of gas, which is I'm spending more time on it, and it's also like the last part of the presentation. It has diurnal variations, which means it variates during the day. So it has daily cycles as well. So according to daily cycles, when it comes to mind, which is the thing that will give the most impact on it? So it is the traffic and the air pollution caused by the cars. So that is usually during the morning office timing. So you can see like we have higher plots during 9 AM to 12, and then NO2 is broken down by the sun energy, which is why from 12 to 3, when the Tropome was passing over Toronto, we had lower measurements, but it's not like they are not correct, because always whenever there is a yellow point, there are red points around it. Same goes for the total column. I have a peak here, which is for the office timings, and then the Tropome measurements were made here. Now once again to the Tropome maps. during June. I have a longer time interval because the Trupumi data wasn't available for like the same time duration of the time. So this is a longer time interval, and this is shorter because I wanted to show the peak. C part is till July 13th, second highest AQI, there is a clear peak here. Now, we have two maps for a total column and tropospheric column. Since NO2 was a different gas, you can see there are less like variations in the cloud because it is more affected by the daily diurnal variations. But this was interesting to me. So let's once again decide whatever we learned. Conclusions. Lower air quality day July 13 coincided with the enhanced CO and HCHO columns due to transported wildfire smoke. So to answer our question, yes, we can measure wildfire smoke plumes by correlating it with the AQI in downtown Toronto. The transport of wildfire smoke plumes directly impacted air quality as seen in all of the columns. CO and SCHO, which were the same type of qualities, peaked simultaneously, reflecting similar transport and emission sources, whereas the NO2 peak occurred before and after the lowest air quality day due to differences in the lifetime reactivity and other sources such as local pollution. Once again, I like this video very much because CBC always keeps showing it, and I found the original source. So instead of going to CBC, you can directly go to 5mo.ca and maybe beat them and post your own blog. So for acknowledgements, I want to thank CGCS for the great internship opportunity, my first research internship, Professor Kimberly Strong for her, what's the word?
Mentorship.
For her guidance. I need guidance for saying guidance as well. Fatima for all of the problems that I keep facing up with the co-op things. Darby for our supervision. Kevin Joshi for answering multiple questions. Petra for helping in troubleshooting. Kabir Cameron overview for helping during the internship. Professor Kelly Walker as well. And everyone else in the group. Thanks a lot.
Yeah. So we learned a lot about like the emission spectrum and that sort of thing first about wildfire smoke. Have you thought about any like preventative measures or like what you can do, like what applications this can have, what your work can do?
Yeah, so for wildfires, again, it's like something which is not in humans' control. But since we were saying like it is not harming all of the gases, since NO2 seems to be caused by our own controls. So I can go back to this slide where it tells like what is the problem that NO2 causes. So if we reduce traffic pollution, there are better like public transport, electricity and stuff, we can maybe prevent irritation of the lungs. But yeah, many of the things are not in our control, but it's good to know their impact. And if we know their impact in this season, we can learn from it and better like global things can be adopted. Yeah.
Yep.
Thank you for your presentation. I was wondering if you found that the anonymous sensor that is at the top of the building mapped what you were finding with your more detailed measurements, and whether or not an off-the-shelf instrument can match all the wonderful scientific instruments that you were using.
Yeah, that is like again a like new direction for research. But the thing was like during the less time that was correlating directly to the AQI, which has like different things. So I didn't get into theory of that. I was directly measuring the gases, but I will surely look into that. Thanks so much.
Okay, thank you so
Thank you.
much.